Hello, everyone. Paul here. Today we are going to go through the meteorology review sheet, which is pretty short and it ought not take that long. So over here, I have the meteorology review sheet that I literally just downloaded from my courses just to make sure that I had exactly what y'all have. And then over here, with the same thing, I have the notes that I also just downloaded from my courses, so that I'm sure that I have what you have. And so yeah, so let's just go ahead and go through this. So I begin with just a very fundamental question. What's the difference between weather and climate, right? And so this is a mistake that people make a lot, but not surprisingly, it's right here where it says weather versus climate. Let me move something out of the way, and there we go. If I do that, I can do this and I can actually highlight it, and there we are. And so yeah, so weather is just a state of the atmosphere at a given time in a given place. Whereas with climate, what we do is we average those data over longer times and larger spaces so that we can look for trends and things like that. So that they really are two different things, right? A cold day doesn't mean global warming isn't happening, and a hot day doesn't mean that it is happening. So global warming is, of course, climate. Don't confuse it with weather. Okay, so then we turn our attention to the atmosphere itself and what is it made of. And so there's two kind of different things we have here. We have fixed components that don't change and variable components that do change. Okay, and so the fixed components are kind of the gases that we think about being in the atmosphere, and here they are right here. Um, mostly nitrogen. so about 78% nitrogen, 20%, 21% oxygen, and then, a bunch of other little stuff, carbon dioxide, argon, etc., etc. The main thing I want you to know here is that it is mostly nitrogen, not oxygen. So just kind of keep that in mind. And then the next question asks about variable components. So these are things that will vary from one place to another, right? So the percentages of the fixed components don't change. It doesn't matter where you sample the atmosphere. It's going to be 78% nitrogen, 21% oxygen, and kind of 1% other stuff, right? And so, yeah, the variable components, though, as the name would imply, vary. Okay, and so there's a few of these, and they're right here under, well, variable components. First of all, of course, is ozone. Ozone is O3 as opposed to the oxygen that we breathe, which is O2, and it is very different, right? At the ground surface, it's pollution. Higher up in the air, though, it is good because up there it blocks ultraviolet radiation. The other variable component that we talked about was water vapor, which is just humidity. We live in Florida, y'all. You know all about humidity. Okay, just keep in mind that water vapor is an odorless, tasteless, and invisible gas. Right? If you can see it, it's not water vapor. It's water liquid, like clouds and steam and fog and stuff like that. And then the third variable component that we talked about are aerosols. These are tiny particles, droplets of dust and salts and liquids and oils in the air. Like a lot of things, they're not inherently bad, but if you have a lot of it at the ground surface, it's pollution. But it is also important, though, because the aerosols scatter sunlight. And so you don't need to be in direct sunlight on the surface of the earth to be able to see. You step into a shadow and it gets darker and cooler, but not utterly dark and utterly cold the way it would, for example, on the moon or something like that. And so there we go. And then question number 4, I ask, okay, what are some of the things that meteorologists study in the atmosphere, and or rather measure in the atmosphere? And so here they are. It's in our case, it's not that many, not that much, right? So first of all, you want to know what the temperature is, right? It's hot, it's cold, it's the temperature. It's really measuring the speed of air molecules, and it's actually in the real world different from heat, but we're not going to go there. Okay, we're just not. And then, of course, another thing that we measure is humidity, which is the water vapor in the air. And I went through a whole thing about relative humidity, where if you say the relative humidity is 80%, that means that the air is holding 80% of the water vapor that it could hold. And then, of course, the trick there was if you lower the temperature, you lower how much it could hold. And so you can actually raise the relative humidity by lowering the temperature which I know seems kind of counterintuitive, but if you're not sure, just go back and have a look at it. But also, it's not going to play a role probably at all on the test, so don't worry too much about it. But yeah, and then of course air pressure, right? Air pressure is the weight, if you will, of the air. Let me not do that. There we go. Air pressure is the weight of the air, quote unquote, pressing down. 14.7 pounds per square inch, 1,013 millibars, 1 atmosphere, 30 inches of mercury, however you want to measure it. On the ground surface, high pressure is nice weather, low pressure is nasty weather. So if you want to predict the weather and you can only know one thing, that one thing you want to know is the air pressure. Okay, so there we are with that. And then we talked a bit about weather patterns. What is the difference between the summer and wintertime pattern, and what causes these differences? And it's right here, underneath where, oddly enough, it says weather patterns in Florida, right? And so the wintertime pattern, we get, oddly enough, cold fronts, right? And so normally you get a warm, humid air mass sitting over Florida. In the wintertime, colder air can push down from over Canada, and that creates a cold front. Okay, what happens is that warmer air pushes the cooler air pushes the warmer air up over it, and when air goes up, it cools. That leads to condensation, and that leads to precipitation. Right? I think I've said this kind of over and over again in classes. The way you get it to rain is you get the air to go up. There's a number of ways to get it to go up. One of them is to push it up over another body of air. And so, yeah, so there that is. And let me see. So let me highlight this, okay, so that we have this. And what I'll do is I will upload these highlighted notes as well, although I feel like I'm highlighting just pretty much everything so far, but that will not always be the case. And so, yeah. And then the summertime pattern, here's the weather forecast in the summertime, right? Highs in the mid to upper 90s, clear in the morning with scattered afternoon thunderstorms, which is, pretty much the weather forecast for the entire summer. And so what's going on there? Well, as with, as I said over and over again, the sun doesn't heat the air, right? The sun heats the earth, and the earth heats the air. Okay, in the summertime, the sun comes up. It takes it a little while, but the sun will heat the earth will heat the air, and that warm air rises. When air rises, it cools. It cools till it can't hold its moisture anymore. That makes a cloud, and then it cools even more, and that makes rain. And so that's where our scattered afternoon thunderstorms come from, is what we would call convective heating and convective rising of air. And so there we go. Okay, so then we turned our attention to climate change. And the first thing we want to understand is, how is the Earth warmed, right? And one more time, and I know you're sick of hearing this, and I'm frankly sick of saying it, but the sun doesn't heat the air, right? The sun heats the earth, and the earth heats the air. The thing we want to add, though, here is greenhouse gases: carbon dioxide, methane, and water vapor. Mostly, those gases trap heat. Okay, and so, yeah, that's not inherently a bad thing, right? If it wasn't for greenhouse gases, it would get down to be negative 250 at night, and nobody wants that. Okay, but when you add more heat trapping gas to the air gets warmer, right? And since the Industrial Revolution, we've been doing just that. We've been adding carbon dioxide to the air as we burn fossil fuels. But anyway, there's that. And so let me see, how is the Earth warm? What is the carbon cycle? How does that work? And here that is here. So you frequently hear that trees, and there's other sources of carbon dioxide other than people, and there are. But the point behind me talking with you a little bit about the carbon cycle is that, yes, trees put a lot of carbon dioxide into the air, but they also take out a lot of carbon dioxide. In fact, they take out twice as much as they put in. And under natural circumstances, yes, there is a lot of carbon dioxide moving around the air, around our atmosphere. The problem, of course, is when we burn fossil fuels, we pump more carbon dioxide into that cycle than it can handle. And so that extra carbon dioxide accumulates. And one more time, when you add more heat trapping gas to the air gets warmer. And so, yeah, these should be little little subscripts, but I'm not going to change them because I'm just not going to do that. And so yeah. Okay. Climate feedback. So the thing is, the Earth's climate is rising. The Earth temperature is rising a lot faster than you might expect it to, and that's because there's a lot of what we call positive feedback. There's a lot of things out there that gets a little bit warmer, and something happens that makes it even warmer. Okay, and so what are those? Well, first of all, ice, glacial ice. And also sea ice here is a problem, right? And I place that under the category of albedo, which is a fancy word for the sunlight that is reflected, is the Earth's albedo, right? Glaciers and ice of all kind keep the Earth warm, not because they're ice and they're cold, but because they're white and they reflect sunlight. Okay, sunlight that is reflected is not turned into heat. And I talked with you about this already. It's the difference between walking up and down a nice white sandy beach and walking across an asphalt parking lot. Same time, same place, same sun, right? But a different surface. And the surface makes a big difference. And once again, the reason the surface makes a difference is because, I'll say it one more time, the sun doesn't heat the air. The sun heats the earth, and the earth heats the air, right? So the surface that light hits on the earth matters, and it matters a lot. And so yes. And so another important feedback is water vapor. Water vapor is a greenhouse gas. So as we heat the planet, you increase the evaporation rate, so you get more water vapor. The good news is water vapor has a very short, what we call residence time. It doesn't stay in the air long. Rain is water vapor coming out of the air. Okay, and so yes, it's a greenhouse gas. As I was saying, class, water vapor doesn't really keep me awake at night. Methane keeps me awake at night. Okay, because methane is a very powerful greenhouse gas. It has a number of sources, but one of them is melting permafrost. Permafrost is soil that is normally frozen year round. And as we're warming the planet, we're melting permafrost, and that's releasing methane. There's also frozen sediments releasing methane. There's a lot of stuff out there that's releasing methane. And so as that methane goes into the air, it warms the planet, which melts more permafrost, which warms the planet. You see how that works. And so yes, okay. So those are the feedback. So what are the consequences, right? What are the consequences of a warming planet? Some of them we're just having to deal with, right here in Florida, right? And so I just listed them here, and that's really all I need you to do is just list them. And so, sea level rise, right? As we melt ice on land, as we melt glaciers, not sea ice. Sea ice is already in the water. No one is out there suggesting that if you melt sea ice, you raise sea level. You don't. Okay. But if you melt glaciers, like say Antarctica or Greenland, right, that's ice on land that's now flowing into the water, making the water deeper. That's sea level rise. And don't forget also thermal expansion. Right, and we talked about both of these when we talked about beach erosion, but thermal expansion, right? Everything in the universe gets bigger when it gets warm and smaller when it gets cold. Everything does. It just does. And so as you heat the oceans, literally the oceans get bigger, and that causes it to lap up on land. Also, ocean acidification. We mentioned when we were talking about the carbon cycle in class that the ocean can take up, I think it was 2 gigatons more carbon dioxide than it is currently taking up. And it is, but that's bad because that acidifies the water. And there's a lot of life in the ocean that really doesn't like that at all, including coral reefs, which serve as an important economic engine for a lot of countries, but also are important in terms of wildlife habitat and stuff like that. I showed you a very striking graph of the increase in weather-related disasters. We're seeing, more hurricanes, stronger hurricanes, wetter hurricanes, hurricanes carrying further inland. We're seeing more floods. We're seeing, more droughts, which is weird because we're getting too much water and not enough water kind of at the same time. Fire season is out of hand. And yeah, we're just seeing more of that. And then keep in mind that the more of that you have, the more money you have to spend to fix it, right? Every time a hurricane makes landfall, that's money that we have to spend mitigating that. And so, yeah, so, okay, so, and then I ask, what role? And here's a typo. This should be do. In fact, the computer even knows this should be do. What role do prevention, mitigation, adaptation play in our climate response? Right, and so yeah. So here we go. Right. Okay. So I looked at this earlier, and here's what I'm going to do. Rather than highlight all of this, really, if you just know what these are, right? So prevention, keep it from happening, right? That is that simple. Now it's too late. It's here. We can't prevent global climate change. Global climate change is happening. Okay, it's too late to prevent it. But there it is. Where we really are right now is mitigation, right? Trying to make it not so bad, working on reversing it, working on lowering that curve, however you want to think about it, right? Just because you can't stop it from happening doesn't mean you can't turn it around, because you can always turn it around. And I talked about a lot of things here, but really, I just the top line is what I'm going to worry about. Okay, so don't worry about having to list any of this stuff, or it's a multiple choice test or whatever. So yeah, so just this the top line stuff, right? And then of course, where we also are is adaptation, right? We're having to learn to live in a warmer world, and if we do that intelligently with some foresight, it's better than just going around trying to slap band-aids on everything all the time. And so, yeah, so there we are. Okay, and I believe that's the meteorology review, y'all. So I highlighted these notes as we went. I will upload the highlighted notes so that you have them. I know I mostly just highlighted everything. I'm sorry. But y'all taken you've already taken a test for me, so you kind of know how it's going to be. So I will upload this video, and I will upload these highlighted notes here. I'll scroll down here where not everything is highlighted. There we go. I'll upload these highlighted notes, and I'll send out an email letting y'all know that it's done. Okay. Alrighty, y'all take care, and as you're studying for the test, get with me if you need me. Shoot me a text message, shoot me an email. I'm checking both of them, so I'll be happy to help you out with any issues that you're having. Okay, bye-bye.